Starting with some notes, in particular the intermediate value theorem. Once again, I mentioned this yesterday that if a theorem has its own name, it's important. This is a big one. You've used the intermediate value theorem already, you just never called it this, or did you address it? But the stuff that we use the intermediate value theorem for, you've done in at least pre-calculus, if not further back. So let's start with this. Suppose you got a girl that's 5 feet tall on her 13th birthday. Keep it all right, I'm not going to read that to you. Go ahead and read that. Yeah, her knees would be shot. Okay, so is the concept fairly straightforward? There is no point in time where you all of a sudden wake up one day and you've grown 3 or 4 inches. Your growth is a gradual process over time. So every possible height between your birth height, which is really kind of the birth length because they don't stand you up, but your birth length and your current height, every single possible value between those two numbers, you must have been that tall at some point in time. Does that concept make sense?
Yes.
Beautiful. So let's say you were born at 21 inches and you are now 6'2". Somewhere along the line, you were 3 foot 6 inches. You were 5 foot 7, etc., etc., etc. Okay. If that makes sense, then intermediate value theorem will be pretty easy. But it builds off of what we talked about yesterday. The idea of human growth, as it says up there, is a continuous function. You didn't jump over any distances. There was no point in your life when you weren't 4 feet tall, unless you're now shorter than 4 feet. But I think we're good to go in here. Okay. So now we drag the math into it. This theorem has a hypothesis, and the hypothesis is that it's continuous. This does not apply unless you know the function is continuous. So one of the first things you'll have to do with the intermediate value theorem is prove that it's continuous. And most commonly, you're going to do that by stating it's a polynomial. You'll either be told it's continuous, or there will be a way to show that it's continuous. And then it's real simple. You start at a y value, you end at a y value. You have to cross every number along the way. So in my picture up there, if I start with f of a being at 1 and I end with f of b being at 5, I must have crossed every possible number at least once, going from a to b. It doesn't mean that I couldn't have hit it a bunch of times. You might have been 5'2" for an extended period of time. That could oscillate back and forth. Sine graph, for instance, could hit all those values a ton of time. But what it's saying is it's got to hit it at least one time. How are we doing so far? Good? All right, how do we apply that? Most commonly, IVT is used to find zeros. Okay, so here's a function. X cubed plus 2x minus 1, what can you tell me about it, Ben?
It's continuous.
Why?
Because it's a polynomial equation.
Excellent. What else can you tell me about it?
The third degree should have, there has the possibility to have 3 roots.
Good. If we knew what it was equal to, but we don't. Right. Okay, anything else? What's the basic shape look like? Okay, good enough. So if you draw, in your notes, if you sketch a cubic, and you intersect that cubic with the x-axis, we've talked about this already, but you'll see you have a variety of different possibilities. It can cross the x-axis once, it could cross 3 times, it could hit it twice. We're going to figure out whether or not it crosses, and if it crosses the x-axis, that's what we call a 0. So we'll use the intermediate value theorem to figure out whether or not it has a 0. So, first things first, as Ben said, we have to establish that it's continuous. And this one you happen to know that it's continuous because, as he said, it's a polynomial. It must be continuous. Then I need to know, where am I starting and where am I ending? So if I'm going from 0 to 1, how do I figure out what y values correspond to those x values? Quase que vem. Então, vai ser. Ah, não é. Au. This is awkward.
Plug it in.
Plug it in. Figure out what f of 0 is and figure out what f of 1 is. What's f of 0? Negative 1. What's f of 1? 2. I think, right? 1 plus 2 is 3, minus 1 is 2. Okay. Therefore, we're starting at negative 1, we're ending at 2. Somewhere along the line, I must cross 0. You can do it for any value, but like I said, its most common application is showing whether or not there's a 0 in the function. Okay. So, there it is summarized. F of 0 is negative 1, that's our starting point. F of 1 is equal to 2, that's our ending point. If it goes from negative 1 to 2, somewhere along the line it's got to cross the x-axis and give us a 0. Now, notice that function won't tell you where it crosses the x-axis. It just tells you there's got to be at least 1. There could be 2. There could be 3, depending on the function. Could be a lot of them. Okay. But again, the only thing IVT does for you is tell you that at least one of them have to exist. Does all of that make sense? Awesome. 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 We're done. Okay?
That was suspiciously easy.
I don't have a response.
I feel like it should have been.
So I'm contemplating my options here. One option would be encouraging. Oh, it's not. It's just that easy. One would be sinister. Oh, wait, there's more.
I'm sure there's more. That's the scary thing.
I'm just going to go with the lack of response.
Okay.
And let the future determine our outcome then. Okay, so we are. Let me explain one basic rule that happens in this class. I'm sure many of you are aware of the fact that AB is taught by myself, Mr. Grassi, and Ms. Feline. If you didn't know that, now you do. The rule is the following. If anything goes wrong, it's Mr. Grassi's fault. If everything goes well,
It's your fault.
I did it, right. So the calendar, you'll now notice, is off another day. Everything was great. We were fine. And then Mr. Grassi got his little mitts in there and started sliding stuff around. What's important is that you realize we're on day 14, even though day 14 is tomorrow's homework. So we've got day 13 and day 14 both out there. They both are about continuity. So it seemed to work well in the past where I moved around and helped people. If that method proves to be most advantageous for most of you, if not all of you, then I can continue with it. If it would prove better for me to go to the board and do problems for the whole group, I can do that. But what I'm going to do today is stay with the new method and just move around the room and help people that have questions on day 13 or day 14 as you get into it. And then again, in a week or so, we'll reevaluate. If you're realizing, oh wait, I'm not getting my questions answered, or there's other questions that we're not addressing, then we can switch up the approach here. Okay? Yes, sir. That's next on the agenda. Yes. I don't know yet. I'd rather quiz the same thing. We're gonna move the quiz. Even though we're off a day, we're going to keep the quiz on the new day Monday. Because I don't want to quiz before them, because then they'll cheat off of your knowledge. And I don't trust those other kids as far as we can throw them. So we're just going to stay away from those degenerates and just quiz them. Are you leaving? Trade one for the other? It's like baseball time.
I had a question and I forgot it. Oh, you guys like that?
Got it right here, I'm working through it. Well, okay, so let's figure out the slider scale. What would you interpret as awesome, good, okay, bad, or real bad? Now you remember we're on the grading scale. So that would be an 8.
Definition of essay.
95.
Did you read it?
Oh, I write this down.
Fastest I think a teacher's ever graded. She hasn't graded mine.
75.
Would you include an exclamation? Okay, 2.
I got all of them.
2?
75.
3. Good.
75 to 89 is good.
Is good?
You didn't do the range, so you have 89.
70.
Yeah.
Come on, it's easy to count.
Really? No. 70 to 74 is
74.99.
okay.
That's a close range.
I'm gonna spell it out.
And then anything before that, anything under that is real bad. No.
Anything
No.
under
65 and up is bad. Below 65, yeah, real bad.
That's real bad.
What do you do?
Where's the bad?
Do a frowny face.
They're just skip bad.
Yeah, good.
So like, how many real bad bats?
Now you realize that this is a B.
Oh, That's still okay. That's okay.
But in our eyes, it's still bad.
That's bad. That's real bad.
Because at 10,
Come on, man.
I'm gonna save yours so you guys.
Yeah, Jesus.
You didn't even notice.